Alright, so next we come to part B of question 3 on the midterm. So this is slightly more straightforward than part A in the sense that you know exactly what you need to do to find this. And so you're given probability of A is equal to 1 over 3. I'm just going to restate the question. Probability of B is equal to, no, you're given probability of A is equal to 1 over 4. Probability of B is equal to 1 over 3, and probability of A union B is equal to 1 over 2. So if A and B are independent, if A and B are independent, then probability of A intersection B is equal to probability of A times probability of B. What do we know? Do we know probability? Do we know A intersection B? Probability of A intersection B? No, we don't. But we know all the information we need to get that, right? So what is probability of A intersection B in terms of probability of A, probability of B, and probability of A union B? Probability of A intersection B is equal to probability of A plus probability of B minus probability of A intersection B. So this formula is all we need to calculate probability of A intersection B. Whoops. I meant union B over there. Right? So probability of A intersection B is equal to probability of A plus probability of B minus probability of A union B. So now we have these three values, don't we? Which is equal to 1/4 plus 1/3 minus 1/2. What is 1/4 plus 1/3? Let's take a common denominator of 12, right? So this is 3 plus 7, not 7, what am I doing? Plus 4, 3 plus 4 gives 7, minus 6 over 12, which is equal to 7 minus 6 over 12, which is equal to 1 over 12. Right? Now what is probability of A times probability of B? Which is equal to 1 over 4 times 1 over 3, which is equal to 1 over 12. So we've shown just by calculation, just by hard calculation, that probability of A is equal to probability of A intersection B is equal to probability of A times probability of B. That's all we need to show. Therefore A and B are independent. True. Again, I want to mention a few of the mistakes people made on this question. People took this statement here to be true only if A and B are independent. But that's not true. This statement here is true all the time, and it is true regardless of if A and B are dependent or independent or disjoint or whatever, right? So that was the mistake number one. And then number two, what people did was they seemed to equate disjoint and independent, treating them as the same thing. But disjoint and independent are almost opposites of each other. If you know that A and B are disjoint, then you know that if B happens, A will not happen. That gives you a lot of information about A, right? If B happens, then you know for certain that A will not happen if they're disjoint. That is quite literally dependent on each other. Information about B completely tells you that A will definitely not occur. So that shows you that A and B are not independent if A and B are disjoint. So in disjoint is almost the opposite of independent, in the sense that it gives you a lot of information. Therefore, that's the other issue, that people equated independence and disjoint, and that is not true. And people also mentioned, I guess this falls out from the second part, that people thought that if P of A union B is equal to P of A plus P of B, then they are independent. Then they are independent. This is not true. So this again stems from from question 2, or from the error 2, where people thought that disjoint and independent were similar, or were the same thing. If A and B are disjoint, then this happens. But disjoint and independent are not even close to being the same thing. Therefore, this does not show independence. So these were the three common mistakes people made in part B, and I just wanted to point those out. All right, so that's all for part B, and let's move on to part C for problem 3 and the midterm.